Hey friends, good morning. I hope every one of you are doing well. So today we are going to discuss about the daily lead code challenge problem that sort the matrix. Like really lately, I wasn't placing the videos for this daily challenge, but have placed some videos and links over my channel, my LinkedIn, as well as my Telegram for job openings, specifically for the batch of 2022 and 2023. So if you are from the desired batch, go and watch them, have a look. Maybe this helps you out in some or the other way, or maybe that opening is specifically for you. So it's gonna be a good help for you guys. Okay, so now let's talk about the question which we are going to discuss today. So the question is, sort the matrix diagonally. That's basically a lead code medium question based on diagonals and arrays. A quite easy one comparatively, if you know the concepts, and if you don't, then obviously it's going to be hard. Talking about this question could be asked in fact specifically based on your phone screening round, or mainly in the initial TR phases where they ask easy medium questions. This is tagged by Google questions too. So have a clear look how this goes on. Now let's see what the question says. The question says we have a matrix diagonal. Okay, so talking about what is a matrix diagonal. So if you have a matrix, okay, so a diagonal is anything that starts from one endpoint, okay, and it goes down to the bottom right. Okay, if it starts from the left, it goes down the bottom right. And if said opposite, if it starts from the rightmost point, it goes down to the bottom left. So that means it starts from topmost and ends at bottommost, but in the alternate direction. If it starts from left, it goes to right. If it starts from right, it goes to left. So that's what a matrix diagonal is. And for every particular you can say size of a matrix, we have different diagonals that goes up. Now, given an m into n matrix that's named as mat of integers, sort each matrix in ascending order and give the resulting matrix. So we have to sort the diagonals. Okay, as you can see this matrix given. Okay, let's see it here itself. Let's create one matrix on our own and then look at what they want to say. Okay, 3 1 3 1. Let's give this 2 1 1 2 1 1 2 3. Okay, this is not sorted yet, so let's make this as 2. Yeah, now see, this is your matrix. Let's look at the diagonal. So the first diagonal is apparently only 1, nothing happens. Second is 2 1. Third is this, then this, and obviously these two. Now, if you see these diagonals, are they sorted? No. 2 and 1, it should be 1 and 2. Again, 3 1 2, it should be 1 2 3. Talking about 2 1 3, again 1 2 3 and 2 3. So this is the matrix that's given to you. And what should be your resultant answer that you want is, okay, just a minute. Okay. So what you want is this matrix diagonal. Obviously the ones are fine. Then 1 2, then 1 2 3. Again it's 1 2 3, and then 2 3. So this is what you want should happen, right? So as you can see one thing, okay, things I guess are fine right now. 2 3 1 2 3 1 1. Yeah, seems out to be fine. 2 3. Okay. So what you have to do, you have to make the diagonal in a proper way that it works out fine. Okay, this is how your sorted goes up. Now let's come to the question and then work accordingly. Now we'll go with the method that could be followed to solve this question. Okay, let's have some values here. 1 2, oh sorry, that should be 1. This is an additional test case, not the one given in your LeetCode. So it's good to go off with an additional one so that it's easy for you. Now what we are going to do is, to solve this problem, we know one thing, that somewhere or the other we need all this in ascending order, right? We need something that stores the diagonal values and returns it in ascending order, right? That means you need some kind of a data structure that will take each diagonal's values and return them in ascending order. So if I ask you what kind of data structure this could be, so I guess priority queue is the most well-known thing. If you talk about, if you're not aware of priority queue, so I've explained one of the questions too, and if not, then you can say a basic data structure that in which we store some values in such a way that it has some priority associated. If not, then they are done in ascending order. Okay, so this is what we are going to use now. For having this priority queue, what we need, first we need to iterate. Okay, now talking about this priority queue elements, there's something that comes up. How can you say this is a diagonal? Not every diagonal has I equals to j, right? There is some other concept that comes up. So let's place these indexes first. Okay, let's talk about this diagonal 3 2 1. I and j 0, I and j 1, I and j 2. So this is the I equals to j1. Now talk about this diagonal 1 and 0, 2 and 1, 3 and 2. So can you see one thing? This I minus j, this is always constant for any particular diagonal. Look here, 2 minus 0 is 2, 3 minus 1, 2, 1 diagonal. Come here, 1 minus 0, 1, 2 minus 1, 1, 3 minus 2, 1. So to get a particular diagonal, you have to check that its elements, that's I minus j, is constant. If you know I minus j is constant, you can store those values and get the priority queue. So the priority queues that are to be created is equal to the number of unique values you get for this particular element. Expression, sorry, not element. Okay, so this is how we are going to approach the problem. I hope this concept is clear to get any particular diagonal. Now for this, if you know I is gonna go from 0 to 3, j is gonna go from 0 to 2. What you have to do, you have to check. We have to create a map. Okay, create a map. That map points from integer value what? This I minus j, and a new priority queue associated with that value. Okay, why? Because we need to check that this is unique. So if we have these many values, it will store all this. Now I minus j. So first we need to check if we have this I minus j value, then it's fine. If not, then you need to create a new priority queue. So if we have this value, then what we are going to do, let's say it's mp.get this value, and for that we are going to add the value of sorry, it should be your a of I, or you can say j, or matrix of ij, whatever you want to name it. Okay, this is what has to be done. Now let's actually see for this particular code how it goes up. So coming to the point, if you have to get any particular values arranged in a set or ascending order, and you want to optimize your solution, don't go up for an array based solution again, sorting it using some values. It's better go up for a priority queue. If you are aware of it, it's really a wonderful thing. Then coming about diagonals, so for fetching any diagonal, the easy method is that I minus j is going to be constant. Okay, now let's go. I'll store the difference, that's I minus j here, and the priority queue values comes up here. So initially I is 0. Okay, let's make this here 0, 1, 2, 3, and j goes from 0. Okay, I think this goes wrong because, yeah, I goes from 0 to 2, j goes from 0 to 3. Okay, this seems fine now. Okay, so if you ask which is the third diagonal, 0 minus 3, okay, that's 0 minus 3, minus 3 this one, and then the last one, this comes from 0 minus 2. Okay, so first let's find out the difference. So I'll write the difference in such a way that it points to these elements itself. So the very first is going to be 0 comma 0, then 0 minus 1, 0 minus 2, 0 minus 3, again 1 minus 0, 1 minus 1, 1 minus 2, 1 minus 3. The last one comes up to be, okay, let's remove this. Yeah, 2 minus 0, 2 minus 1, 2 minus 0, and 2 minus 3. Okay, so you know that 0 will point to this element, this, and then so on. Okay, that's what the element you have to fetch. Now, talking about the unique values which we are getting for this differences, we are getting minus 3, minus 2, minus 1, 0, 1, 2. Only these elements are coming up. Now, you have to create the priority queue in such a way that it comes up to be an accurate value. We'll iterate. Okay. The difference we got is 0 for each. We created a priority queue initially, but every time we are not going to have all the values first. We are going to check. Let's say we got 0. There was nothing. We'll add 0 and create a priority queue for it. Okay. Now 0, the value for 0 is 3. Right, 3 here. We got minus 1. Okay. Minus 1 came from 0 comma 1. So the 0 comma 1 value. The 0 comma 1 value should be added in minus 1. So that comes up to be second one. Okay. Then 0 minus 2, that's minus 2. 0 comma 2, that's 1. Okay. This comes to 1. So this should go with 1. Again comes to the minus 3 1. Minus 3 comes from, it comes from 0 comma 3. 0 comma 3 is 1. Add this one here. Again, we got, for the second one we got 1. 1 comes from 1 comma 0. 1 comma 0 is 1. Add this here 1. Again 0. 0 comes from 1 comma 1. 1 comma 1 is 2. Now see, initially we had 3, we have to add 2, but it's a priority queue, so 2 will come first. Again coming to minus 1. Minus 1 comes from 1 comma 2, so it's 1, again priority. Okay, comes from minus 2, 1 comma 3, 3. It's greater one, so it will go back. Priority. Again, comes to the next one, 2. It's 3, 1. Again coming to 1. Okay. The value for 1 is 1, again 1, so for the same value you can place it same. 2 comma 2, it's 1, so it's 0, and it should have 1 like this before. Last one is minus 1, so minus 1, the value was 2, again it's repeated, so it will get 2. Now this was how we created it. Now coming to the point how we are going to store it. Okay, So for storing it, what we are going to do it, for storing again we are going to use this I minus j concept. We are going to use the I minus j concept, but we are going to use, let's say PQ was our priority queue, so we'll use PQ dot poll. What does PQ dot poll do? The poll function will call up the head and will remove it. So we know what are the I and j values. So first for 0, okay, talk about 0. 0, do the poll function. So head is 1, remove it and make this. Okay, again the minus 1, remove this and place it here. Minus 2, remove this, place it here. Again minus 3, so minus 3, again remove it and place it here. 1, okay, so it's 1 again. 0, second one, remove it, place it here. Minus 1, it's 2, remove this and write it here. Minus 2, again remove this and write it here. Okay, comes to 2, that's 3, write it here. 1, again that's a 1. Okay, 0, again remove it and write it here. And minus 1, that's how you have. Now check your diagonals. Are they actually balanced? 3, 3, that was already balanced. 1, 1, already balanced. 3, 2, 1, we got 1, 2, 3. Again, 2, 1, 2, we got 1, 2, 2. 1, 3, 1, 3, and 1. So you can see now these diagonals are balanced. That means they are sorted. So I hope this is clear how it went. It's not at all, you can say, a difficult one. It could go a little lengthy description because I actually wanted you to get each and everything in a clear way. So that's all. Let's see the coding. It's quite easy. Again, having hash map for storing this integer, that's your difference, and priority queue. First find out the difference. Now this is the function which we use. If it's not there, put if absent. If it's not there, then create a priority queue. If it's there, then come to this, get and add this. Now once you have this, what you have to do for storing it back to the matrix, that's an in place one, call the app and do the poll functions. Okay, now talking about what's the time space complexity. If we talk about in terms of m and n, so m and n goes here, and then talking about the diagonal length, it goes with k log n. Okay, so this is going to be your time complexity. I hope this is clear. If in case there were any queries with the solution, do let me know in the comment box. This is a very standard question and it's quite beneficial if you get the concept. So ping me if there is any doubt, anything that comes up. Till then, keep following Tech Geek.